Okay, so in this one you've got a diagram like that, where you've got 2 there, a 1 there, and you've got a height. Now, remember you had that formula? Or if you didn't have the formula, you could work it out. So you know a half base times height equals 1. So you know a half times, what's the base? 2 times height equals 1. So what does the height equal? 1. So we know that's 1. So that's cool. Alrighty. So that was A, evaluate the height, done. Okay? So A, the height was 1. B, write down the equation. So that you've got to get the syntax right. F of x equals, and do that funny curly bracket thing. And we need the equation of this line here. What's the equation of that line? We could do it the real slow way, or if you know that that's the point 1, 1, you actually know that line is y equals x, otherwise known as f of x equals x. So you would know that it's x, and that would be 4 between 0 and 1, x is in the middle. Okay? If you couldn't see that, anyone can't see that? You can use the formula. We'll use the formula for the next one, just so that you know what it is. So the formula you need is y minus y1 equals mx minus x1, where m is the change in y over the change in x, or y2 minus y1 over x2 minus x1. You can choose 2 points on the line, so let's choose those 2. And so I'm going to call this one, I'm going to say x1, y1 equals 2, 0, and x2, y2 equals 1, 1. Okay, so here y2 minus y1 over x2 minus x1. So what do we get there? -1. So we've got a gradient of -1, and then we're going to plug in either of these points. I'm going to choose this point because it's quite handy having the 0. So I'm going to go y minus 0, so that's my y1, equals m, which was -1, times x minus x1. So that becomes y equals -x plus 2. Because -1 times -2 is +1. So I'm going to have -x plus 2 for between 1 and 2. Okay, and 0 elsewhere. Okay, now because I'm prone to error, I actually am going to check. I'm going to plug 2 in. -2 plus 2 is 0, that works. I'll plug 1 in, 2 minus 1 is 1, so that's sweet. So I'm happy that I got it good. So an alternative to the 0 elsewhere would be to have this area here, which is 0 for x less than 0, and then I could look at this area here, 0 for x greater than 2. So then I've kind of got it in order, but you could just have 0 elsewhere. Okay? Okay, I'm going to slow down by popular demand. So here's my graph. I've got 1 there, 2 there, 0 there. Compare it to the rule that's in the book. So that rule had an A, a C, whoops, get it right, It's got an A, a C, a B, and a 2 over B minus A. Okay? Is that cool? Because that's actually in the diagram. So what's our height here going to be? What's our A? 0. What's our B? 2. So 2 over B minus A is 2 over B minus A is 1. Okay, so it's alright if I take that away and actually just write 1. Okay, so I substituted the A and the B into here to get the height. So that was A, calculate the height. So is that okay now? Yeah, okay. So now we're looking at B. Write down the equation. So our probability density function is actually a line there, a line there, a line there, and a line there. So it's a piecewise function. So we're going to do it in 4 parts. I'm going to get rid of that so that I've got room. Okay, so we've got 4 parts of our piecewise function. So the syntax for this, we look at the example where it's got f of x equals and a big curly bracket. So this part here is comma 4x less than 0. This part here is going to be 4 x between and including 0 and 1. So I can put the x there and do that. So that's the green part. Then this is the blue part. So for a 1 x to 2, so x between there and there. Okay, and then orange. This bit there is 4x greater than 2. Okay, so we've got 4 parts. Now, what's the value of f of x? Sorry, my syntax is bad. What's the value of f of x here? This is f of x on this axis. 0. Okay. And what's the value of f of x here? F of x is the y-axis, so what's this? 0. Okay, so you could have alternatively, instead of having this and this, you could have gone 0 elsewhere, which is less mathematical in my thinking, but that's okay. Okay, so now we're looking at this piece here. So all we need to find is if this equation went on forever, what its equation is. Okay, the equation of that line. And because it goes through the point 0, 0 and 1, 1, we know it's y equals x. Yeah? Or f of x equals x. We're good now? So now we've just got the one last tricky one, which I showed you before using these rules. So with these rules, I'm going to call that one there 1, 1, and that's going to be my x1, y1, and this one here is 2, 0, and that's going to be x2, y2. Is that okay? Yeah. So the equation of a line is y minus y1 equals m x minus x1, but m equals the gradient, which is change in y over change in x. Change in y y2 minus y1, change in x, x2 minus x1. Alternatively, we can look there and there. I can actually see that that gradient is negative 1. I can actually see that it's negative 1 gradient. Anyway, y2 minus y1, so 0 minus 1. x2 minus x1, so 2 minus 1. So I've got negative 1 over 1, which is negative 1. Okay? So whether you actually read that off the graph and you know that that gradient's negative 1, or you did it with the equation, doesn't actually matter. Well, the important thing is that gradient of that line is negative 1. So I'm just going to get rid of that so that I've got a bit more room. There we are. Okay. So now I know that my gradient is negative 1. I can go y minus y1, which was 1, equals negative 1 x minus x1, which is 1. I chose the wrong point. The other point would have been easier, but it doesn't matter. So y minus 1 equals negative x plus 1. Negative times negative is positive. And then this plus minus 1 becomes plus 1 on the other side. So we get y equals negative x plus 2. Yeah? So negative x plus 2 for that section of our triangular probability density function. Okay? Did I get it right? Yes, thank you. That's better?